don't have like an EOC for this, right? We have the exam that you give us.
Right. Just a semester.
You know, if we have an EOC for history, right? U.S. history.
I thought civics was the last one.
I'm saying,
Yeah, civics. No, same.
I don't know. Is there a U.S. history?
Yeah. I don't know, but I pull in myself from the toe of it.
Alright, so we are simplifying. I'm going to show kind of a lot of work to simplify this because today we're going to simplify polynomials. So we'll have like variables and things involved. So just getting our heads right into how simplifying works. So
Number one.
Sure, what would I do next? So I'm going to see, and you do this mentally. I know, you don't show this work, and that's okay. But I'm showing what's going on in our heads. Oh, just clearing the zeros, so you can just cross those out, and it's 2 fifths, right? The reason we can do that is if we wrote these as factors, 2 times 10 and 5 times 10, those are 2 factors of 20 and 2 factors of 50. You can reduce common factors top and bottom and get 2 fifths. That's just different vocabulary into talking about simplifying fractions. So number 2, Matthew, how did you think of 26 and 13? You probably just divided it, right? So this would be 2 times 13 over 1 times 13. That's writing something in as factors. The 13's reduce, and you get just a 2. Number 3 is 4 times x and 4 times 6 times x, if you wrote it as common factors. So the 4 is reduced top and bottom, the x is reduced top and bottom, we have a 1 up top and a 6 down below. No, the x's, since there was 1 up top and 1 down below, we reduced common factors.
And then
Number 4. 10 times x, 3 times 10 times x. These are factors, split up with multiplication. The 10's reduced, the x is reduced 1/3. And then number 5 is clearly different than the rest. How is number 5 different?
there's addition,
Addition. So I just want to take a moment and just really reflect. When there are plus signs in between numbers, you cannot cross out. We cannot reduce this. We can't say that 13 over 15 is the same as 3 over 5. Those are not equivalent. So we cannot cross out with addition. It's just something I really want to drive home here. Cannot cross out. Reduce is the best word. Parts of sums. Parts of sums. So this is 13 over 15, which have no common factors other than 1. Those are, well, 13's prime and 15 doesn't divide by 13. So that doesn't get reduced, 13 over 15. Simple as it goes. Any questions on both work? Yes, yeah, both x's, more x's. Let's do it. All right, so we're starting chapter 8. This will be your last 100-point test will come from this content that we're starting today. You don't have to write all of this. This is 8-1. It comes from page 529 of the textbook. These are definitions and words right from your textbook. So, rational expression is what we're working on here. Rational has the root word ratio. Rational and ratio come from the same root word. So a rational expression is just a ratio of two polynomials. So all of these things on the board are fractions. You could call them ratios. But they're generally not considered polynomials unless there's x's involved or variables involved. So we're looking at fractions with polynomials, a polynomial over a polynomial, like number 2 here. This is what we're working on. So we're going to simplify ratios of polynomials today. So to simplify, we're going to divide the numerator and denominator by their greatest common factor. Look for common factors and cross them out, just like we did in these simple fractions here. So number 1 is just like what we did in Bauer. 8 over 12 can reduce, and that's because they both are divisible by 4. You know, if you write 8 into 2 times 4 and 12 into 3 times 4, you cross out the 4s, you get 2/3. That's all done mentally for you. You've done that for years. So looking at number 2, this says you must factor before reducing. I'll show you what the wrong thing to do is. This is what everybody does instinctually. People do this wrong. Yeah. Alright, so on and on, you'll do it today, you'll do it again in a month, you do it on 5 exams, you do it next year. People will do this. And they'll cross out expert over expert. Why can't we do that? You can't do it. This is just like number 5. Could you cross out the 10? No, because it's not multiplication. Okay? If it's not multiplication between your terms, you cannot reduce. Yeah, it's like plus and negative. I guess I should make those plus. You cannot reduce well, there's like nothing we can do if it isn't multiplication. Right, so breaking 8 and making it 2 times 4 is factoring. That's factoring a number. And breaking 12 and making it 3 times 4 is factoring. So we're going to factor these polynomials so that we can write them as a product. And then we will be able to reduce it. So for 2, we have to factor the top. So we need to know what will multiply to 3 and add to negative 4. And that's for the numerator. And for the denominator, we have to multiply to 5 and add to negative 6. So this whole chapter is really contingent on factoring. So if you never got factoring, this is kind of your last chance to figure it out. You won't pass the test if you cannot factor. This is probably the most important test for factoring. So what multiplies to positive 3 and adds to negative 4 would be negative 3 times negative 1. So I'm going to rewrite that as x minus 3, x minus 4. Notice that this is now multiplication. So whereas this was addition and subtraction, we've now written this as a product. That's going to help us reduce it. Oh, I messed that up. Thanks, Jackson. All right, what multiplies to 5 and adds to negative 6? Negative 1 times negative 5. All right, so now we have these factors we can now reduce. I can cross out x minus 1 and x minus 1. You don't even need the parentheses now. That's the answer. So factor and then reduce. Which is exactly what you did in Ballard, but you're factoring numbers and now you're factoring polynomials. So this note is really important. Must factor before reducing. That's the key of the whole lesson. One other really important note for this lesson is identifying excluded values. I've talked about this only once before this year. I mentioned this once before. I'm showing you one problem. I remember it was when we were adding, subtracting, multiplying, and valuing polynomials. I mentioned it. And I remember it because I knew how significant it was going to be this week. We talked about it a lot this week. Excluded values means anything that will make the fraction undefined. You can't work with numbers that leave zeros in denominators. It's no good in the math. So as soon as you start putting x's in denominators, undefined values become present. For this fraction, there's two values that would make the fraction undefined. So I'm going to say that x cannot be 1 and x cannot be 5. As far as the variable goes, x could be anything else. But 1 and 5 ruins the fraction. A 1 would give me a 0 here, which is undefined. Mathematicians won't work with zeros and denominators. And a 5 would result in a 0 here. And we can't have zeros in denominators. So these are excluded. Yes. You could just make these equals. Well, these are going to be more complicated possibly. So you make them equal 0 and you solve it. You know, like you're solving a 0. And so now that I did include 1, even though I crossed 1 out, I include it in my excluded values. So your excluded values come before reducing. I'm going to note that here. That's important. You look at the fraction before reducing to identify excluded values. Some people might just put 5, but that 1 has to be in there. They will end up becoming really important for graphing. There'll be holes in the graph. This graph looks something like this. There's 1 and there's 5. Our graph is going to loop through here. Something like this. Can't eyeball in this. It'll have a branch there and a branch there. So we will be graphing these rational functions. And so our graph will come really, it'll come really close to approaching 1, but it can't be 1, so it zooms down. takes a while to figure out the graphs. But we'll spend time on it. There's a portion of this graphing that we do open note because there's a lot to remember. All right, let's try these two. All right, so your directions will read simplify. Identify any values that make the expression undefined. So I'm going to give you time to write it. And then I'm going to factor this quadratic. Max, how do you factor that one? Max, factor that yellow. Can you factor it? Mm-hmm. All right, Holly, you do the blue one.
Wait, so like if there's no C value, do you put in C?
Actually, there would be no b value there, like x squared.
Oh, is it x plus 3 and x minus 3?
Mm-hmm. Yeah. This is what multiplies to -9 and adds to 0. It's also called a difference of two perfect squares, so you can just square root the 9. X plus 3 and x minus 3. So now that everything is factored in its multiplication in between terms, I can cross out x plus 3 over x plus 3. Mm-hmm. Yeah. So this is my answer. I'm not going to ask you to like FOIL or distribute or put it in standard form. Leaving your final answer in factored form is great. But we do have to do undefined. And you might read, find excluded values or undefined values. X can't be 6, x can't be -3, and x can't be 3 because they create zeros in denominators. Mathematicians don't like it. In number 2, those are z's. Those are all z's. So there's only one thing to factor. Right there. You want to factor it, Matthew? Which one's positive and which one's negative? Does it seem like we factored a lot? Like, does it seem like we factored a lot this year? Not recently. The ACE math teacher said we need to factor more. More factor. No, let's cross out the 5s. I don't know why they're in there. Let's cross out the 2s, the -2s. More factoring. That's our answer. And we'll say z can't be 1, z can't be -5, and z can't be 2. From this one. Yeah. Yeah.
So what do you mean the z can't be 4? So it's actually thinking
This one there. Because 1 minus 1 makes 0. -5 plus 5 makes 0. 2 minus 2 makes 0.
I thought you were only doing ones that were crossed out.
No, complete opposite. You do the whole denominator before crossing out. This is the answer. This is simplified. These are the excluded values. Two parts to it, yeah. Because there's 2 directions: simplify, identify values that make it undefined. There are times where you'll have to use -1 to simplify. Opposites. If you observe perfect opposites, those can be reduced. So, Jacob, how would you factor this numerator? Can you rewrite it in any way? It can be rewritten. It has a greatest common factor. Z. Take a z and put it in front. And that leaves you with x minus 4. Now these are perfect opposites. This x is negative. This 4 is negative, while this 4 is positive. These are perfect opposites. They both have to be opposite. So I'm going to reorder this so I can see it more clearly. I'm going to reorder the bottom one so that it looks like the top one. Kind of a lot of work to show, but when I reorder it, I get negative x plus 4. Because the x was negative and I'm putting it in front, the 4 was positive and I'm putting it back. So now I can see even more clearly that these are perfect opposites. So I'm going to factor in -1 out of the denominator. So it's z x minus 4 z squared times -1 times x minus 4. Taking a -1 out will make this positive and this negative. It changes their signs. So now I have matching factors that can be reduced. So what we're left with is z over negative z squared. You can reduce mentally, or if you want to show the work, that would be negative z times z. One of these z's reduced, and this is negative 1 over z. There's a lot of work there that you can make mental math. Just kind of showing the whole process. So for this one, z cannot be 0. And z cannot be 4. Oh, that was a mistake all the way through. Oh, wait a minute. Yeah, it would be x. That's an x there, Torian, thank you. From this little guy here, even going here, if I put a 0 in here, 0 squared is 0. And then 0 times this makes everything 0. So if it's just a variable, not in parentheses, one of your excluded values will be 0. Like here you can even see, like I can't put a 0 in here, so z can't be 0. More work for one little innocent problem. We ready to move on? Yes? Yeah. So we're working towards these. Refactor 4 in one time. I mean, I think I can keep that for tomorrow. Let's just do one more of these and I'll let you start your assignment. Seth, you should put your phone away and do this problem. Next, you should put your phone away and do this problem. What do you think about the top there, Seth? Do you see any greatest common factors? They both have A, both terms have A, and both terms have B. So we're going to take an A and a B and put them in front. If I take an A away from them, I get B squared minus 5B. If I take a B, B minus 5. This is a really big topic in pre-calculus too, so pretty much no matter what, next year you'll be working on this topic all over again, no matter what math you go to. Besides that financial class, you won't do this in that financial class. All right, watch this. All right, do you believe me that B minus 5 and 5 minus B are opposites? All right, so what if we just cross them out and put a negative 1? Not show anywhere. It doesn't matter. Might as well put it on top. If you believe me, what I did in the last problem, that these two things are opposite and they reduce to negative 1, don't show any work. Cross them out and put negative 1 in. As long as you believe in it. Do you guys want me to show all the work again? Right. It doesn't matter. You pick where you put it. Just don't put it in both places. I am going to show the work really quick. But if you guys want to skip ahead, that's fine too. So this would be AB, B minus 5, all over 5 less B, negative B plus 5. So I'm going to reorder this one. And in this one, I'm going to take out a negative 1. when I take a -1 out of b minus 5, it looks like -1, negative b plus 5. It'll look like -1 on the outside and b minus 5 inside. And then I can cross out. So it's up to you where this negative comes into play. But I'm going to make this negative AB up top, 5 plus B down below. There's like 4 different ways this could be written. It could be A times B up top and -5 minus B down below. Or you could leave the -1 in the front. That would be okay too. There's several different correct ways to write this answer. So I'm going to say here that B can't be -5 and B can't be +5. No, because A is only in the numerator and undefined values come only from denominators. Okay, you can start your workbook now. Yes.